Lesson 2, multiplication of numbers in exponential form. You're going to complete a discovery activity with a partner to investigate rules for multiplying powers of the same base. Take each expression from question 1 and write an expanded form, and then write the expanded form and put back into exponential form. So 3 times 4 would be 3 times 3 times 3 times 3. And we're going to multiply that by 3 times 3 times 3 times 3 times 3 times 3 times 3. And all of that would be equaling 3 to the 11th power. Here we have 10 times 10 times 10 times 10 times 10, which would equal 10 to the 5th power. Here we have negative 5 times negative 5 times negative 5 times negative 5, times negative 5, and then times negative 5 times negative 5, and all of that would be negative 5 to the 7th power. Here we have x times 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 x, and all of that would be x to the 7th power. So now the question says, how can you get directly from the original problem of 5 to the 3rd power times 5 to the 5th power, to the answer of 5 to the 8th power without expanding the expression? Is there a shortcut? Well, the answer is yes. You could add the exponents. So by doing so, use the shortcut that you found to find the missing value in each expression. So here we could say 5 to the 3 plus 4. So our answer here would be 5 to the 7th power. Here we could say negative 3 to the 2 plus 5 would equal negative 3 to the 7th power. Here would be 1.2 to the 3 plus 3, or 1.2 to the 6th power. Here I would have 3 over 5. Now this actually is, because there's nothing here, means it's to the 1st power. So it would be 3 over 5 to the 1 plus 3 power, or 3/5 to the 4th power. So our next, so in general, basically what all of this is saying is any two number, or any x, in other words, it's got to be the same base, okay? And as long as the numbers are positive, we can add them together so that we can have the same base and add the exponents together. So now for exercise 1, we have 14, and it says simplify by writing the answer in exponential form. So we have 14 to the 23 plus 8, which equals 14 to the 31st power. Question 2 says a to the 23 plus 8, which again is a to the 31st power. Exercise 3 is negative 3 to the 9 plus 5, which equals negative 3 to the 14th power. And here it says let x be a positive integer. So if negative 3 to the 9th power times negative 3 to the x power equals negative 3 to the 14, what is x? Well, because all three bases are the same, we can take their exponents and make it an equation by saying 9 plus x equals 14, and then solving for x. So we can subtract 9 to both sides and say x equals 5. Now it says, what would happen if there were more terms with the same base? Write an equivalent expression for the problem. So it says, simplify the following by writing your answer in exponential form. Well, to do that, all we would have to do is say 3 to the 4 plus 5 plus 2. So that would be 3 to the 11th power. So our next problem, we have, it says, simplify the following by writing your answer in exponential form. So now we have 9 to the 4 plus 5, plus 6 plus 13, which would equal 9 to the 23rd power. Exercise 6 says 2 to the 3 plus 5 plus 7 plus 9. So when I add these all together, well, 3 plus 5 is 8, plus 7 is 15, plus 9 is 24. So 2 to the 24th power. And I'm sorry, that looks like a 9, so let me rewrite that. Make sure it looks like a 4. Okay. Example 2 says, can the following expressions be written in simpler form? If so, write an equivalent expression. If not, explain why. Well, it can be written in simpler form, but we have to be careful because it can't be all written with one number. It has to be written with 2. So it says, simplify the following by writing your answer in exponential form. Well, the first thing we have to do is put our bases together, here, here. So we write them in order. We have first our 2's. So we have 2 to the 5th times 2 times 3 to the 4th times 3 to the 2nd. Well, that's going to equal 2 to the 5th plus 1 times 3 to the 4 times 2, or plus 2. Sorry, let me redo that one. So now we have 2 to the 6th times 3 to the 6th. And that's as far as we can simplify that. So it says, what do we do if we have an expression such as 5 to the 4 times 125? Well, we must have the same base. So in this case, we can take the 125 and we can simplify that by 5 times 5 times 5, which equals 5 to the 3rd power. So now we can say 5 to the 4th times 5 to the 3rd, which equals 5 to the 4 plus 3, which equals 5 to the 7th power. Next, we have, to simplify, it says, and write in exponential form, 2 to the 5th times 16. Well, 16 can be written as, well, let's put it over here. 16 can be written as 2 times 2 times 2 times 2, or 2 to the 4th power. So now we can have 2 to the 5th times 2 to the 4th, which would be 2 to the 5 plus 4, which would equal 2 to the 9th power. So let me erase this. So now to simplify the rest, we have 6 to the 5th times 6 to the 14th times 4 to the 9th times 4 to the 3rd, which would equal 6 to the 5 plus 14 times 4 to the 9 plus 3. And again, remember your smaller number goes first, so I'm going to put 4 to the 12 times 6 to the 19. Next here we have 2 to the 4 times 8 squared. So the 8 squared can be written as 2 to the 6th power. So here we've got 2 to the 4 plus 6, which equals 2 to the 10. Here we have 15 to the 2nd times 15 times 7 squared times 7 to the 4th equals 15 to the 2 plus 1 times 7 to the 2 plus 4. So we have 7 to the 6th power times 15 to the 3rd. Next we have 5 to the 4th times 2 to the 11th. Well, these are different bases, and they cannot be written with different or with the same base. So in this case, we can't do anything here. So this is going to stay the same as 5 to the 4th times 2 to the 11th. So now simplifying the following by writing your answer in exponential form here, what we can do is our numbers can be multiplied together and our x's can go together. So we have 4 times 12 and x to the 2 plus 5. So here 4 times 12 is 48. X to the 2 plus 5 is x to the 7th. So next we have 2 to the, so here we can rewrite the expression in simpler form. So here we've got 2 times 17 times x to the 3 plus 7. So now we have 2 times 17 is 34. The x to the 10th power. Our last question says the floor of the lobby at start point middle is in the shape of a square with the side lengths of x squared by y to the 3rd. So the new tile is going to be put on the floor. Find the area. Well, area equals length times width. So here we got x squared y to the 3rd times x squared y to the 3rd. So here we can say x squared times x squared times y to the 3rd times y to the 3rd. So we have x to the 2 plus 2 times y to the 3 plus 3. So our answer here is going to be x to the 4th, y to the 6th. That ends our lesson.